We're given f of x equals square root of x and g of x equals x squared on the interval 0 to 1 on the x-axis. And we're rotating about y equals 1. So first step always is to graph. These are fairly easy graphs since they're parent graphs, nothing fancy. F of x equals the square root of x will look something like this on 0 to 1. And g of x, which equals x squared, will look like this. And then we rotate that about y equals 1. And that will give us a solid like that. So since these are two separated regions, I'm going to use the washer method to find the volume. And this washer is going to look like this. And if that's not clear, I'll bring it out here. So this is what we're going to be trying to find the volume of. And first we need to find the area, and then we can find the volume. So the area formula for a washer equals pi times the outer radius, quantity squared, minus pi times the inner radius, quantity squared. Now, the outer radius would be this distance from here to here, that distance. And the inner radius would be this distance right in here. Hopefully that's dark enough for you to see. So, since we're rotating about y equals 1, it's not going to be just the function. And I'll explain that to you. So this distance, we went up 1, so this distance is 1. Let's find the outer radius first, which would be x squared, the pink line right here, or the pink curve rather. So if we said that the radius was the value of x squared, that would actually be this distance right here, and that's not what we're looking for. But this distance, x squared, plus some value here, will give us 1. This value here is actually what we're trying to find, is the radius. If we go back to our washer from the top of the inner circle to the outer circle. So by that logic, the function x squared minus 1 will give us the value that we're actually looking for. So the inner radius is going to be x squared minus 1 quantity squared. And then applying the same thing to the inner radius, if it was just the function, which is the square root of x, that would give us this distance. But we're looking for this distance. And those two added together would equal 1. Therefore, f of x, which is the square root of x, minus 1 would give us our actual inner radius, and that's going to be the quantity squared for the area. Now we can FOIL these out, which would give us x to the 4th minus 2x squared plus 1, and x minus 2 square root x plus 1. And then if we rewrite this, we can simplify it as pi times x to the 4th minus 2x squared plus 1. Distribute this negative, minus x plus 2 square root x minus 1. And we can simplify this further. as pi times x to the 4th minus 2x squared. These ones will cancel out, minus x plus 2 square root of x. And that is our area. Now the volume, we simply have to find the integral of this on our interval 0 to 1. So the volume equals, we can keep the pi outside of the integral since it's a constant, from 0 to 1 of x to the 4th minus 2x squared minus x plus 2 square root of x dx. And integrating that equals x to the 5th over 5 minus 2x to the 3rd over 3 minus x squared over 2. And this is going to be x to the 1/2, so plus 2 x to the 3/2 times 2 over 3, which would give us 4 over 3 x to the 3/2 from 0 to 1. And when we plug 0 in, it's going to equal 0 since all of them have x in them. And then, so we just need to plug in for 1, which would give us pi times 1/5 minus 2/3 minus 1/2 plus 4/3, which would equal 11 pi over 30.